So at the end of the last part of this lecture, we posed this question. I'm going to push an air puck, and we're interested in what it does after it leaves my hand. And I gave you these options. And so now let's do the experiment. So like I said, I will be just off the screen on the left, and you will just see the puck come across the screen. So here we see the puck, and you can see the motion diagram track being produced there, and that is clearly constant velocity motion. I'll put in the whole motion diagram, and I will zoom in, and it becomes even clearer that this is constant velocity motion. And again, it's even clearer that the puck is moving with uniform velocity motion if we look at the position versus time graph, which here is very clearly a straight line. So what can we conclude from this air puck experiment? Well, first of all, I am sorry to say that there's no experimental evidence that I'm a Jedi. That's very upsetting. But on the upside, we can make some conclusions about motion. There's no horizontal force acting on the puck, which might be a surprise to you. And we see that the puck moves with constant speed. Now, as well, it moved in a straight line. And so moving with constant speed in a straight line means it was moving with constant velocity motion. Its velocity vector was not changing. And we know what that means. That means that the acceleration of the puck was zero. Right, we're now able to state two very important laws. The first is that objects move at constant velocity when no forces are acting upon them. Now notice, being at rest is one way of that happening, because something at rest has a velocity that is zero, and that's constant. But it can also mean something moving along with constant speed in a straight line. This is a very important law. It is called Newton's first law. It's also sometimes called the law of inertia. This word inertia sometimes gives students trouble because they think of it as a quantity you can measure. It isn't really a quantity you can measure, although as we'll discuss later, mass is sort of a measure of inertia. But what we really mean by inertia is that this is a characteristic of motion, or a characteristic of moving objects, that they move at constant velocity in the absence of forces. So just as a characteristic of living people is that they have functioning brains, a characteristic of moving objects is that they have inertia. In other words, they move at constant velocity when no forces act on them. And then the second law, which we're not quite ready to state fully, is that forces cause accelerations. So I said when we first saw this that we would come back to it and we'll eventually make it much more specific, and eventually we'll have it in this form, which is Newton's second law.